Frequency distributions. Frequency distributions are going to be a set of data that we have to organize in this table below. And this table is what we're going to call our frequency distribution. How I'm going to set up the table is all given in the directions right here. So it's going to tell me to use 5 intervals. Here's a really important part right here. Width of 57. And also it says I'm going to start with 30. So starting with 30 is how I know to start with 30. Now width of 57 means I'm going to add 57. And it's really tempting when we add 57, 30 plus 57 gives me 87, to put the 87 right over here with the 30. We can't do that. That's why I have this work right here, right now. So we do 30 plus this class width of 57, that gives me 87. Then I add 57 again to get 144. Add 57 again to get 201. Add 57 again to get 258. Then I can go back, and the classes are supposed to take up every number. So if the first class started at 30 and the second class started at 87, that means this one had to go 30 to 86, just one below this. Now another way to do it is to say the class width is 57, so I could always go one less than that and get 56 and do 30 plus 56 to get that 86. They're both kind of the same amount of work. It's just how you want to think about it. If you want to use the actual class width, that's always going to tell you where the next class starts. And then you have to kind of go backwards, back up one to get where your other one ended. Or you can kind of already do the backup thing, 57 minus 1 to get 56, and add that to get you to the end of your first class. So again, I started with 30. I added 57 to give me 87, and I'm like, okay, 87, what comes before 87 is 86. That's how I got my 86 on this side. Now, the next part is I'm going to go through and I'm going to find all the numbers that are between 30 and 86. And this is kind of the tedious part. So between 30 and 86, I'm going to kind of highlight all the numbers that are between 30 and 86 here. And hopefully I can get them all in the first run through at this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 numbers that are between 30 and 86. Now I want to find all the numbers between 87 and 143. So between 87 and 143. So 1, 2, 3, 4, 5, 6, 7, 8. Let's see. I'm missing one. Oh, there it is right there. 1, 2, 3, 4, 5, 6, 7, 8. And there's the last one, 9. So these 9 numbers are between 87 and 143. I'm going to keep doing this for each one of my classes. So the next one is between 144 and 200. So that one's going to be easier, a little bit easier to see. So 1, 2, 3, 4, 5. And then between 201 and 257. So these two guys, so that has 2 of those numbers. And then I've got 1 number left, which is good because I'm out of highlighters. There's 1 number that's in that last class. Now you can always check yourself. Just add those up real quick. That added up to 30, and that is how many numbers I had in my list. So that's how we come up with this frequency distribution. Now I'm going to take this frequency distribution and make a histogram. A histogram is going to kind of look like a bar graph. It's not a bar graph. A histogram uses our numerical data, and the bars, the rectangles, actually touch. A bar graph, the rectangles don't touch, and it can use qualitative data as well. So with my histogram, I'm going to make sure, big important part, that I label the axis. My vertical axis, my y-axis is going to be the frequency, and then my horizontal axis, in this case, was our monthly electric bill, And you know what? I'm going to go through here and actually say that's in dollars too, because that's the units I was using for this. Now, each one of these classes is going to be a rectangle. So 1, 2, 3, 4, 5. I'm going to make sure they touch. I'm just going to make it go all the way up. This top one's going to go to 13. So on the grid paper that's in our notes packet, I have plenty of space just to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you don't have to put the number up here, but just so you can see, I made a rectangle for this first class. You can shade them in or you don't have to shade them in. For the next one, I'm going to make a class that goes all the way up to 9. The next one's at 5, 2, and 1. And then I'm going to list out the class values here. So this one goes from 30. The next one starts at 87, then 144, then 201, 258. And then if you were to add 57 to this, you would get 315 for the next one. We don't actually have a class width down there, but that's how I got that number, 258 plus that 57 class width. So that is a histogram. Now, some histograms, including this one, have special shapes that have names. So I want to go over those. So these are shapes of histograms. So this first one is called uniform because they all look like they're the same height. Like a uniform, if you have to wear a uniform to work, everybody wears the same thing. So these have roughly all the same height. The second one is called normal or symmetric. Symmetric because it's the same on the left as the right. Sometimes we also call this the bell-shaped curve. We use it in a lot of our standardized testing. But we have a nice little hump here. These next two kind of go together. They're skewed left and skewed right, and that's actually the graph that we have right here. Our graph is skewed right. We got a little drawing here to kind of show you the direction because it's really easy to mix it up. We want the direction name to be where the tail is. That's what we call these guys, or the tail, like an animal that has a tail. And I have a kind of silly way to remember this. If you think about like a little blob monster, I'm going to draw my little monster here. There he is coming after you. He has a tail. His tail's on the left, so we call this skewed left. Over here, his tail would be on the right, so we're going to call it skewed right. This is where their tail is how they're skewed. And what is going on here is we're having data that's pulling everything toward the right. So here, this one is kind of outside of everybody else. It's a higher bill than everybody else. So it's pulling the shape of my graph down, and it was on the right-hand side. Over here, it would pull my data to the left and actually changes the mean. The mean, instead of being in the middle, it's going to be pulled down to the left or right. The last type is bimodal. And we're going to talk about modes as we go along. But mode is the number that occurs the most. And so this actually has two humps right here. Kind of like two of these normal distributions on top of each other. So it has two modes. That's why we call it bimodal. And we're going to talk about a little bit more about the mean, median, and mode in the next section. But basically, the median is really hard to get it to be affected. It's harder to affect with highs and lows. The mean can be affected. So when I have things that are really low or really high, like my skewed, that's going to pull my mean away from the middle. The median stays in the middle much longer. This bimodal is going to keep my mean and median in the middle, but it's going to make my mode kind of split off and have two of them.